Okay, so here, what do you notice about the base? It's a fraction. So the first thing I want to talk about is a over b, a fraction, raised to a negative exponent, is equal to, so you might want to write this rule down, the reciprocal b over a raised to the positive exponent. Would you like for me to explain why? All right, so I'm going to do an example, but did you write that rule down? You don't have to write my example down, but write that rule down. So here's my example to explain why. 2/3 raised to the negative 3 power would mean that 2 and 3 are raised to the negative 3 power. Now go back and tell me, what does 2 to the negative 3 represent? What does 2 to the negative 3 mean? 1 over 2 to the third. Negative exponents make positive fractions. Divided by, what does 3 to the negative third mean? 1 over 3 to the third. So now I have a fraction divided by a fraction. I'm going to write it out with a division symbol because for some reason people seem to do better with fractions that way. So when you have a fraction divided by a fraction, you do what? Keep, multiply by reciprocal. There is the reason why the fraction a over b flips to b over a. Because now I get 3 to the third over 2 to the third, 3 over 2 to the third, which is what we said in the first place, that if you start with a fraction to a negative exponent, you flip it and you can make the exponent positive. Why? Because you end up with a fraction divided by a fraction, which turns into a fraction times its reciprocal. Multiplying by the reciprocal is what flips it and makes the exponent positive. Do I need you to be able to go through necessarily the explanation of all of that? I mean, no. I would hope that you could, but no. You don't have to explain it, but do you need to be able to take a table of values like this and accurately fill in what 1/2 to the negative 2 power is? Yes, I need you to be able to apply the rule at least. So 1/2 to the negative 2 power, I'm going to do what? I'm going to flip it, and it's going to become 2 over 1 to the second power. 2 over 1 is just 2. 2 to the second power is 4. Questions there? So negative exponents do make positive fractions, but if you start with a fraction to a negative exponent, you're going to do the reciprocal to that positive exponent. So then 1/2 to the negative 1 power would be 1/2 to the negative 1 power would flip to 2 over 1 to the positive 1 power, which would be 2. Anything to the 0 power is 1. 1/2 to the first power is 1/2. 1/2 to the second power is 1/4. Graph it. What do you notice this time? It's going down, which is going to lead us to that word called decay. Ever heard of radioactive decay? All right, here you go. Here's your connection to science. Am I still approaching something without ever touching it? What am I approaching without ever touching it? I'm approaching 0 on the x-axis, a y value of 0. I will never touch it. Do not, if that's the case, draw your line going below the x-axis. I'd rather you just Draw it right there and stop and put an arrow. Don't go below the x-axis. That's showing you don't understand that it'll never drop below 0. This is actually called the horizontal asymptote. Whereas with parabolas, we had a vertical axis of symmetry. Now we have an asymptote. An asymptote is a line you will never touch. Now, could that translate up or down? Up or down? Yeah. Because if we said we had a k value, it's going to translate the asymptote up or down. But for just this basic function right here, it is the x-axis because the x-axis represents a y value of 0. All right, let's keep going. What's the initial value up here? Remember, a times b to the x. If there's not an a value there, it is 1. So the initial value here is 1. Does this function display exponential growth or decay? We can tell by the table because the numbers are getting smaller. We can tell by the graph because the entire graph from negative infinity to positive infinity is a interval of decrease. An interval of decrease. Does that make sense? So you are decreasing from left to right. Your numbers are getting smaller. When do you think that happens? What did we notice about this problem to begin with? The base was a fraction. So when do we think it's going to be decay? What kind of fraction? A fraction whose value is less than 1. When do we think it's going to be growth? When the base is greater than 1. Will the base ever be 1? No, because if the base were 1, it would just be a horizontal line. All right, so let's talk about two things now. We've got the decay, what are the two words? Decay factor and the decay rate. The decay factor, a factor is what you're multiplying by. So the decay factor is, what are we multiplying by repeatedly here? 1/2. The decay rate, how far away from 1 is that as a percentage? 1/2 is how far away from 1 as a percentage would be 50%. Be careful, it's not the factor as a percentage. It's how far away from 1 as a percentage. So what if I had something like y equals 2 times 1/4 to the x power? The factor would be 1/4. The rate would be, don't turn the factor into a percent. It's how far away from 1 is the factor. 3/4, and 3/4 as a percentage is, so the rate of decrease is 75%. Because if you're multiplying by 1/4, like let's start with a better number like 40. If you're multiplying by 1/4, how much are you keeping? 40 times 1/4 is 10. Percent decrease is it decreased by 30 out of 40, which is 75%. Percent decrease is how much we're losing, how much it's actually going down by. What you're multiplying by is what you're keeping. Do you see what I'm saying? So if I was going to, again, write a formula, so we have the decay rate would equal 1 minus b times 100. Whereas before we said the growth rate was equal to b minus 1 times 100. Why is it different? Decay is what kind of number for the base? Less than 1. We don't want to have a negative. We're not going to have a negative. And growth is what kind of number? Greater than 1. So that's why we're subtracting 1 if it's growth. We're subtracting from 1 if it's decay. Because you're not going to have a negative percentage. All right. I want you to go to the second page, the front of the second page, and we're going to go through and summarize what we've talked about so far and practice a little bit. So the front of the second page, the left-hand side should look like what I have projected. All exponential functions are written in the form y equals a times b to the x. A represents the initial value. So in the paper folding example, that was what? 0.001, which represented the thickness of the paper. B represents the base, and that tells me the growth or decay factor. That tells me the growth or decay factor. So in the paper folding example, we started with a thickness of 0.001, and we multiplied by what over and over and over? 2, because the thickness of the paper doubled every time you folded it. So we multiplied by 2 over and over and over. X is the exponent, and it just tells you how many times you were folding the paper or multiplying by 2. What values of B make it an exponential growth function? Can anybody answer that question? What value of B makes it an exponential growth? So when B is greater than 1, any value greater than 1, what value of B makes it an exponential decay function, Cole? B less than 1. I'm going to add an and statement here. And we don't want a negative B. Greater than 0. So B will not equal 1. B will not be less than 0. This is not. Will not equal 1, will not be negative. Could A be negative? And what does a negative A value do? Reflects it over the x-axis, but B will not be negative. Sketch an exponential growth function and an exponential decay function. Growth is an interval of increase the entire time. So as you move your pencil from left to right, you're drawing a curve that is increasing from left to right. Decay is an interval of decrease the entire time. If you're focusing on the functions we talked about today, then your curve will not cross the x-axis. So you should have a curve that looks like that for growth and decay. Yes? Take just a couple minutes. It shouldn't take you long. Go through number 3. Label each function as either exponential growth or decay. Look back at number 3. Avery, A, is that a growth or decay curve? Decay. B, Lawson? Growth. C, Daniel? Decay. Looking at the equations. D, Jack? Growth. What did you look at on D to tell that it was growth? The base, the number in the parentheses. Anybody want to tell me what the rate would be if the factor is 3? That would have a rate of how much more than 1 is 3? 2. Write that as a percentage. 2 times 100, 200%. E, Jax, was that a growth or decay? Decay. I looked at what? The base, which was 0.98. That's decay because it's less than 1. Anybody want to tell me what the rate would be there?